Good morning, dear students. My name is Ferhan Mazher, and today is 9th of March 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a paper of alternative to practical. We call this a paper 4, and today we have selected October, November 2016, a 4-1 paper. This paper 4 belongs from the zone 1, or you can say this belongs from the variant 1. So let's start today's paper. So uh, the first question coming up on your screen, the time allowed for this paper is 1 hour. A student investigates how surface area affects the rate of evaporation of water at room temperature. She places a beaker of water on a top pan balance as shown in the figure 1.1. Figure 1.2 shows the beaker on the balance 14 days later. So this first figure 1.1 shows you the beaker at the first day. The mass of the content and the beaker is 235.1 gram, and after 14 days the mass of the beaker and the contents is 183.8 gram. Some water has been lost due to evaporation. Calculate the average loss of mass per day by the evaporation. So we have to uh, calculate what is the loss per day by the evaporation. So first of all, I will find out the loss, and that will be the initial value minus the final value of the mass. And once I know the difference, then I will divide it with the 14, because there were 14 days. So let me show you. So here we go. So that's the solution which I have done. So the loss of mass per day will be equals to 235.1 minus 183.8. The whole thing divided by 14 equals to, it will be 51.3 divided by 14, and that will be 3.664 grams per day. Grams per day. I hope you understand. Okay, so let's move to the next part. He says, so we are done with that question number 1, A part. A second student carries out the same experiment with a beaker of larger diameter. The students compare their results and conclude that the rate of evaporation increases with surface area. State two other quantities that must have been the same in the two experiments if they can be sure of their conclusion. You see, for a fair comparison, uh, both the experiments should be carried out in the same room temperature. That can be the one reason. And the other thing can be that both experiments should be subject to an environment in which the humidity is same, because both these factors, the temperature, the room temperature, and the humidity, they can affect the rate of evaporation. So they should be same. Let me show you my written answer. Okay, so here we go. Room temperature should be same. Humidity level in air should be same. Okay, so let's go to the next part. The experiment took 14 days to complete. In order to carry out the experiment in a shorter time, suggest a piece of apparatus that increases the rate of evaporation. You see, you can increase the rate of evaporation by placing a heater in the room and switching it on. So it will increase the room temperature, so the rate of evaporation will become faster, and you can get your results quickly. So let me show you my written answer. Switch on a heater in the room. So that was question number 1. So let's have a look at the marking scheme. So my dear students, the marking scheme is showing up on your screen. You can pause the video and you can take your time and check the answers given in the marking scheme. It is a very important habit to always check your answers with the marking scheme. Okay, so here we go. A student investigates how the height of a ramp affects the distance traveled by a toy car along the floor as shown in the figure 2.1. The car is placed at the top of the ramp in the position A and then released. The car travels down the ramp and along the horizontal floor. It stops at position B. The car falls a vertical distance h, a vertical distance h when traveling down the ramp. It then travels a distance L along the floor. On the figure 2.1, draw the car immediately after it has completely left the ramp. Mark the distance L, mark the height h. It's a 2-mark question. So let me show you. So here you can see, so this is the height of the ramp from where the car was released. So from here to the front wheel of the car here, that's the horizontal distance traveled by the car, represented with L. And what else they want? Here is the car, which when just came out of the ramp. Off the ramp, we have drawn that car. So these were the 3 things he asked you to draw. So I can hope you understand this. The student The student measures the height h and then measures the distance L 3 times. He then changes the height of the ramp and repeats the experiment. Describe how the student can measure h accurately. You may draw on the diagram if you wish. So it's a 2-mark question. So I want to measure this height accurately. So I will use a scale here. Then I will place a set square here at the floor to make sure that the scale is vertical. And then I will use a set square here to measure the height exactly. When I use a set square here, because there will be some distance between the ramp and the scale, vertical scale. And by using a set square, you see, I will be able to avoid the parallax error. So let me show you. I have drawn that and written the answer also as well. So here you see on the diagram, I've shown a scale. And here is a set square on the floor. This set square makes sure that the scale is vertical. And here I have used the second set square. This is used to measure to actually pinpoint what's the height on the scale. It helps us to avoid parallax error. So let me show you my written answer. Here we go. Place a scale vertically. Use 2 set squares, one to keep scale vertical and other to check height without parallax error. So that was question number 2 and its B part. Now, here we go. So that's on your screen, the C part is showing up. Figure 2.2 is the table of the results. So here we have the height from which the car is released on the ramp. And that's the horizontal distance when the car is off the ramp, how much horizontal distance it covers. And we have done that experiment 3 times. So I will take its average. So here are the 3 things which need to be completed. He says, for the first 3 heights, the student calculates the average distance, L average, L average is written to the nearest centimeter. So just a reason why for writing the L average to the nearest centimeter. So here, when he took the average, he just wrote the average up to a centimeter, not more than that. The reason is, if you look at this data which he used, the the variation in the data is more than 1 centimeter. So that's why he did not wrote here. He only wrote here the average up to a centimeter, because the data, the values in the data, they are very varying from each other more than 1 centimeter. So there is a large variation in the data. That's why. So that was the first part. Let me show you my answer. So the variation in each set of values of data is more than 1 centimeter. So then he says, let me, then he says, complete the figure 2.2 to include L average for all his results. Give L average to the nearest centimeter in each case. So they're talking about this table. So you, in your calculator, you will add these three values, press equals to, divided by 3 equals to. So you will get the average, write it here, add these three values, equals to, divided by 3 equals to, you get the average, write it here, add these three values on your calculator, equals to, divided by 3 equals to. So you will get the average of these three values. Let me show you, I have done this. So here we go. So I added these three values, equals to, divided by 3 equals to, you got 123. So I added these three values, equals to, divided by 3 equals to, I got this number, and to the nearest centimeter, it will be 153. I added these three values, equals to, divided by 3 equals to, I got 187.5, and to the nearest centimeter, it will be 188 centimeter. So this is how you do it. I hope you understand this. Okay, so the next thing they are asking is, on the figure 2.3 opposite, plot the graph of the L average in centimeters on the y-axis against the h in centimeters on the x-axis. Start your axis from 0, 0. Draw the line of best fit. So here's that graph paper. Let me show you. So if you can see the whole thing, okay. So we have to take the L average here and the H here. So it's a kind of 4 marks question. So let me show you my solution. Okay, so here we go. So I have drawn this. On the x-axis, I will represent H in centimeters. So our values are going up to 1 centimeter, 1.5 to 2.5, 3, 3.5 centimeter. So that's why here I've written 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. And you know, the L average values, they are going up to 188. So what we have done here, you see, let me reduce the size so you can see the whole thing. Okay, so 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. And then I plotted those points. At one, it was 50 something, I think. Yeah, at one, it was 54. Yeah. So plot those points. I plotted them and then join them with a smooth curve, best fit curve. You can see there, I have drawn that. So this will get you 4 marks. I hope you understand. Let me increase the size so you can see it more clearly. Oh, this is done. You see, this is the first point. And this is and then we have, this is the second point, the third, fourth, fifth. And then we have the sixth point. And then what I did, I joined them with the best fit curve. Okay. Here, I think I forgot to write L average in centimeters. That's very important. So write in your answer, write here L average in centimeters, put an arrow in the upward direction. So this is how this is done. So what's the next thing? After that, they say, describe the relation between the L average and the age. So if you look at this graph, if you look at this graph, if you look at this graph, as the H value is increasing, the L value is also increasing. They are not directly proportional. Don't use the word directly proportional. They are not. But as the H is increasing, the L is also increasing. You simply have to write that sentence there. So I have written there, as H increases, L average also increases. Then the next question they are asking is, in another experiment, use the same apparatus. L averages measured as 140 centimeter. Using your graph, suggest the values of H that was used. Okay. So from the figure, the graph which I have drawn, here we go. So from 140, I will come to this graph. He says the L average is this. So what is the H value? From here, I come downstairs here, and you can see how much is this reading? 2.75 approximately. So the H value will be this much. 140 of the L, come here, then check what is the H value here. It's 2.75 something. Okay, so that's our answer. So that answer I have written here, 2.75 centimeter. Oh, so my dear students, we are done with the question number 4. So we are done with the question number 4. After this, we are going to question number 3. But before you go to question number 3, let's have a look at the marking scheme. So the marking scheme of the question number 2 is showing up on your screen. You can pause the video and you can take your time and read this marking scheme very carefully. It's a recipe for the success in the Cambridge exam, that whenever you write answers, you always check, compare your answers with the marking scheme. So let's go to the next question. A student determines the specific heat capacity of aluminum. The student has been provided with a thermometer, a heater, an aluminum block of mass 1 kg with holes for the heater and the thermometer, a DC power supply, an ammeter, a voltmeter, a stop clock. On the figure 3.1, complete the circuit diagram to connect the heater to the power supply, the ammeter, and the voltmeter. So it's a 2 marks question. So let me show you my solution. Okay, so here you can see I have connected that heater with the battery here, and power supply, I mean. And here you have connected a voltmeter. The voltmeter is always connected parallel to the heater, and the ammeter is connected in series. So this is how you connect an ammeter and a voltmeter. Okay, so next part. He says, initially, the block is at room temperature, which is 23.5 degrees centigrade. The student switches on the power supply and starts the stop clock at the same instant. The ammeter and voltmeter readings are shown in the figure 3.2. So record these readings. Okay, so here, so what's the reading here? Let me increase the size so you can see. This is the ammeter. So what's the reading? So it's 1, it's 2, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. Okay, so this is 1.2 ampere. And what is the reading on the voltmeter? So this is 8, this is 9, 8.2, 8.4, 8.6. So the reading is 8.6. So 1.2 ampere and 8.6 volt. Let me show you. So You can see I have written these answers, 1.2 ampere and 8.6 volt. Okay, so we are going to the next part. He says, after 10 minutes, the power supply is switched off. The maximum temperature reading on the thermometer is 29 degrees centigrade. The specific heat capacity C of the aluminum block is given by C is equals to IVT divided by M delta theta, where T is the time in seconds during which the heater is switched on, M is 1 kg, and delta theta is the rise in the temperature of the block. Calculate the specific heat capacity, small c, give your answer correct to two significant figures. So we just have to put the values here, the value of the I, which we just noted, the value of the V voltage, and the time is 10 minutes. We don't take time in minutes, we take in seconds. So 10 multiplied 60, it will be 600 seconds. M is the mass, that's 1 kg, which is written here. And delta theta, change in the temperature. The initial temperature was 23.5 degrees centigrade. The final temperature is 29. So the change in the temperature will be 29 minus 23.5 degrees centigrade. Let me show you. The initial temperature was given, yeah, 23.5 degrees centigrade. Okay, so we just have to put these values here. Sorry. So calculate the C. If your answer correct to two significant figures. So C will be 1.2 ampere multiply 8.6 volt multiply 600 seconds divided by 1 kg, and this is the change in the temperature. So when you multiply these upstairs things, numbers with each other, I mean, so you get 6192 divided by 5.5. So 6192 divided by 5.5, it will be 1125.8. But they ask you to give the answer in two significant figures. So you will write, we write 1100 joules per kg per degree centigrade. Okay, so next part. The accepted value for the C is different to the value obtained. Suggest two reasons why this is so. You see, the instrument you used, this aluminum block is not lagged with any insulator. So the heater which is providing the heat, the its loss, its or the heat which the aluminum has gained also, that is it is losing it to the surrounding because there is no lagging of the insulation around the aluminum block. And the second thing, you see this heater is not completely immersed in the aluminum block. Some part of the heater is still outside the aluminum block, so the heater's heat is going into the atmosphere directly. So let me show you my answers. Aluminum block not lagged. So, and heater is not fully immersed in the block. So I hope you understand. So that was the question number 3. So let's look at the marking scheme. So my dear students, this is the marking scheme for the question number 3. You can pause the video and you can take your time and read this marking scheme very carefully. Compare the answers which I have given to you and you have written yourself. Compare them with this marking scheme. It is very, very important habit to do this. Okay. A student is given a box containing 10 similar plastic drinking straws, a 30 centimeter ruler, and 2 set squares. explain how the student determines an average value for the external diameter of the straws using this apparatus. Draw a diagram to illustrate your answer. It's a 3-mark question, very simple. So what I will do, I will place 10 straws side by side. I will place one set square on one side, one set square on the other side along the straws. And on one end, I will on the where the straws are ending, I will place a scale. Let me show you, and I will be able. Then I will measure what is the like this. So you see, I have placed the 10 straws like this, and I put set squares around them, and along this edge, I have placed a scale. So I will check what is the distance between A point and the B point. Then I will divide that a distance AB with the 10, and that will give me the diameter of the one straw. Okay, so let me read the answer. It's a 3-mark question. Place, make this diagram in your answer space and place 10 straws between two set squares and a scale as shown in the figure. Divide the distance between A and B by 10 to calculate the diameter of one straw. He says he says each straw holds an average volume of 4 centimeter cube of water when full. So guess how this value could be checked. You see, the method is very simple. Place the finger on the straw and with the help of the dropper, fill the straw with the water. And then pour that, once the straw is full of water, pour that water into the measuring cylinder. Then repeat this procedure 10 times. So you will have enough water collected in the measuring cylinder. Check what is the volume of that water which is collected in the measuring cylinder. Whatever is the volume of that water, divide it with 10, and you will get the volume of the water which one straw can hold. Hopefully you understand this story. Okay, so fill a straw with water and pour it in a measuring cylinder. Repeat this procedure 10 times. Check the volume of the water collected in measuring cylinder. Divide the volume of water by 10. You get the volume of the water which could be held, by one straw. So, my dear students, we are done with this ATP paper, and today, but before we going to there, before ending this paper, let's pause the video. That's the marking scheme for the question number 4. And just check your answer, my answers, compare the answers with the marking scheme. You should buy the carriage. It's a very important habit. So today, my dear students, we have done October, November 2016, a 4-1 paper. And this was alternative to practical, we say ATP paper. And this paper belongs from the zone 1. I hope that this video will help you to improve the concepts of your physics. It will help you to practice your ATP paper by just sitting at your home and watching this video. If you think that this video is helpful to you, and share the link of this video with your friends, with your seniors, with your juniors, or in O levels, because this will help me to improve my work and promote my channel. So thank you very much, everybody. I'm not feeling well today. That's why I'm speaking very softly, because I have some throat infection, just the seasonal throat infection. Nothing serious, but my sound has changed. So thank you very much. Keep me in your prayers and keep watching my videos. Thank you very much. Have a good day. God bless you all.